Hello everybody, welcome to another stream. How we doing? Oh man, I didn't change anything. Right. Filters. Chroma key. There we go, it's very sensitive as you can tell. Okay, so welcome to another stream everybody, thank you for coming. Yeah, last stream, unfortunately we plugged in the AMD sort code and got it all up and running. We even adjusted our input data and tried to sort something and it didn't work. So we've also changed our sort functions so we can sort just some keys, or we can sort these using an indirect sort where the value is where the number of entries and entries are, I guess, are populated on the GPU. We also have a with payload option, which allows us to sort the keys, and a separate payload buffer, where it sorts the payloads as well along with the keys. But the payloads don't get compared, obviously, only the keys do. And those can obviously be done indirect as well. So we've got this nice API. I just want to test all that, make sure it all works. So it's very easy to debug this, I reckon. And I guess this is my yeah, you know. So basically with radix, it's a radix sort that we've ported over. So the way that it works is that it simply does 4 bits at a time. So this is like 4 bits, yeah. So it does 4 bits of a key at a time and sorts so it sorts groups of 16 on the first level, and then it sorts a group of 16 of those 16 groups. So it just keeps recursing like that essentially. So you'd have it searches at the 4 bits, the 4 low bits first, then it searches the next 4 bits and compares those and sorts. So I reckon if we get the first layer working, then the rest should be quite easy. That's the hope. So we're going to start off by making an array of 16 values where they just use the low 4 bits and just see what happens. So if we literally just like, there's a piece of upload code, right? Upload buffer somewhere. Here, right? So just get something like this. Drop this in here. This is our test code. E32. Well, where's the occlusion stuff written out? Yeah, we'll comment that out. So we'll just go, right, here's our, let's call them W's. Wait. Call these W's. So we're going to upload to the occlusion volume occluders. Yeah. We'll just upload to these guys. We'll comment out the code which sets these. And we're just going to upload 16 values. And all they're going to be is from... Oh, they've got to be random though. They obviously can't be in order. Well, we can make them back to front. And then that it sorts from low to high. So we'll literally just do something like 0 to 16 exclusively, and then just pop in index into there, and then do 16 take index take 1. So that will be they'll start at 15 and go all the way down to 0. So this is only going to set the first 4 bits, right? Because that is 15 in hex, right? So this will mean that when we run our sort code now, I've just got to make sure we don't... This mem sets it to 0 here. Let's comment that out. Then this one, make occluders setup, okay? Make occluders setup. No, not that one. TCAP, thank you so much for the raid. Appreciate it, sir. How's it going? Hey there, Pish Quad. I'll call you Pish Quad X. Welcome, welcome. Thank you for the raid, sir. Appreciate it. Hello, raiders. We're currently working on porting over AMD's parallel sort. So we've got these spheres here that we're trying to render like as many spheres as possible, basically. This is a single instance. We're trying to get the occlusion. So they've got some occluders. They're not really showing up right now because I think I've just taken them out. And with this reprojected depth for the occlusion buffer. And we're trying to sort of, we need a GPU sort function, so we're trying to get this to work. Hey Travis, how's it going? Yes, not bad, not bad. Just yeah, trying to debug some GPU code, so it's just one of those moments. But yeah, things going alright. Yeah, just trying to get to the point where I can have many instances of this volume, which is filled with spheres. I think it's got about 2 million spheres in this volume. Well, it's got less than that. It's 128 cubed. That's what the volume is, but as you can tell, it doesn't go to the end of the volume. So I'm trying to see if I can use an occlusion buffer to like occlusion cull some of these spheres and try to not render all of them, basically. And then when it works on one instance, I'll see how many instances scale up with this method. But yeah, it's not going bad. Got a bunch of glitches, as you can tell. Got some flickering on the spheres. Here they flicker for some reason. And the occlusion buffer just, fails in some cases and just completely cuts holes in my sphere. And you see the clusters and everything. And this is when the tile bins get filled up. But yeah, one problem at a time. 4 milliseconds for 2 milliseconds. Yeah, I'm not quite sure what you mean there. But yeah, oh, did you see me disable and enable this? Yeah, I see. But that's not correct yet. Yeah, but if I have an occlusion buffer, it's like nearly 1. But this is not really correct. But yeah, this is 2 million spheres being binned into screen tiles and ray traced against. But it's not a good test because yeah, I want to make changes to the tile binning code as well. And then I want to also early out when you hit a sphere. Rather than testing every sphere at the moment. Yeah, I want to sort them from front to back, and then ray trace against the ones against the front first. And if we hit something that's opaque, we can early out. That's going to be the plan. But yeah, we're trying to start the occlusion testing code first. So we're just trying to check this AMD radix sort, right? And see why it's not sorting things correctly. So I've just uploaded into the buffer I've just uploaded 0 to 15 into a buffer. I'm just going to sort it. So this is where we copy the occluders. Wait, that's not right. That's where we put the occluders in. So that should be changing that. Right, here I probably want a 0. I don't know anymore. Right, hope it doesn't mess anything up. Let's try that. Okay, so now I want to insert. So this is where the radix sort is happening. It's doing it. It's probably doing it at the right amount of times. I haven't checked that. I imagine it is. So now I want to go into the sort code. So because it's a radix sort, it does 4 bits at a time. It starts at the low 4 bits and sorts, and it sorts based on the first 4 bits of the key. And then it goes and does it again on the next 4 bits, and it keeps going and going. So essentially it's sorting, on the first layer it's sorting things into 16. Oh, this is big. Maybe I'm just zoomed in really far. It's sorting things into 16. Oh, it's definitely big. Get that on. I don't know. So essentially after the first level of sort, you're going to have 16 different groups of things sorted. And this is very terrible. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've missed it. But anyway, essentially you have 5, 6, 7, 8, 9, 10, 11, 12. You know what? Maybe it's better if I find a video that I was watching about it. So we're not all... Yes, this one did it with base 10. But this one does it with base 10 as well. But the idea basically is it takes the first... This one says it takes the first digit and it sort things. Yeah, so as you can tell, it starts sorting stuff from low to high based on the first digit, right? And then it's going to do this again, but on the next digit. And then so... Yes, then it takes the next digit and it will sort things again, basically. There you go. And then it'll just keep going and going and going. So what we've done is, so does it 4 bits at a time, where each digit is 4 bits, if you will. So if we cap this out to 4 for a minute. So let's make it just do the first 4 bits, and then we can just see like, hey, did that work? And then investigate what the issue is. So where we do this, we do a print. I want to do the same sort of thing here. I want to take the occluder, but it's just a U32, and I want to print the value out. Occluder.raw, which is the raw U32 value. It's just all packed information. So this will show us our values from 0 to 16, or yeah, 0 to 16. If I disable my profiling, we should just see it all printed out in the terminal. Right, that's definitely buggered, isn't it? So if we disable the sort code, let's see what this looks like. GFX sort. Did I do size in bytes? Hang on a minute. Did I just do like the count of elements? I did, didn't I? I think this needs to be times size of... That was the problem. Hey there, Katsumoy, how's it going? Hey there, Demi Boss, how's it going? Right, here we go. So we've got 15, 14, and whatever, right? So this is backwards, right? It's from high to low. Let's run the sort function now. And it should sort stuff from low to high. So we're going to sort 16 elements. Right, the order didn't change, which is a bit scary. Oh, because it puts it into the temporary buffer. Right. Yeah. It has two different iterations. So why don't we take this code, and why don't we put it at the end of the shader, which does the sorting. So if you take a look here at the bottom, it runs this iteration here, and it'll do like these 4 shaders, and then there's a scatter, which basically reorders, it is figured out which is the order, where to put the keys in. So we'll basically take from the source keys and put them in the destination keys. And then it will swap the source and destination buffers around and go around again. But we're only doing one loop. So we'll never write it back into the correct buffer. So what we're going to do is in this scatter pass, I want to basically put the print code in there. So here's the source keys, and it will say store key. I don't know why this is a function. It's just how it wasn't in AMD, and I just oh, wrong one. Live now. No. Yes, you got a local key offset. So I guess if we print out 2 integers, we should be able to say, like, they're just indices, right? So I think if they're both the same, then yeah. If they're both the same, then it's correct. Ooh. So what's this local offset thing talking about? Or total offset? There's 16 keys, and for some reason this total offset is always equal to 1, so global offset, local offset, which comes from the scratch, LDS scratch key. Histogram prefix sum. Right. Right, I wonder if we're load the sort bucket offsets into LDS for faster referencing, right? So I wonder if we're not calculating the correct thing to load or something like this. So let's take this with us. And let's just see what data comes in to here at least. Or maybe we are, right? And maybe the data that's in there is wrong. So I want to put in this local ID. And then I want to see what is in there. Just see what the values are. Oh, that is problematic. Right. Let's put it in that if statement. Parallel sort being has at 1024 or something. No. Oh, sorry, I didn't put two integers in there. So it's just getting failed. Yeah, it's parsing it wrong CPU side when it prints it out. Right, okay, so we get a bunch of 0, 1, 1, 1, 1. So this is where the ones are coming from. They're being stored in the, they're coming from that buffer. Hey there, Nico, how's it going? Good evening, good evening. How are you doing? So, why is that wrong? So the sum table was calculated earlier, I think. So, let's put this in here and just see what sort of number we get. Right, so it goes to 0 to 15 in this case, because I guess, yeah, it's the first sort of level or something, isn't it? Okay. Right, so I think something's wrong. I wonder what this bin offset thing actually means. But so at least we've seen the ones come in through here. I'm curious, get the global offset for this key out of the cache. And then get the offset at this point, the keys are all increasing from 0 to number of bins. Number of thread group size. And then total offset. So if we're storing in the same thing, that just feels wrong, right? They're storing into the same place. Right, that's not proper sorting, is it? If all the keys overwrite each other. So, I guess the only other place... So I guess let's get into the first... So the sum table goes in here. It's written to. This is the count. Then there's a reduced pass on the sum table. And it does some scanning. Scan adding. Right, so let's just start at the beginning. And we'll sort of see the inputs and outputs. Well, sorry, we'll just see the output because we know what the input on that one is, but yeah. Right, here we go. So the first one is this sum sort count. This is the sum pass. So we store the sum in here. So again, we'll look at this sort of like, here's the insert index, and then here's the sum thing, whatever that is. So we'll just see what this actually is and just judge whether it's correct or not. Right, it's a bunch of ones. Okay, so let's reason about whether this is correct or not. Currently playing with a new toy. I booted NetBSD 10 over the network on a Sun Ultra 60. And just checked out package source. Let's see how bad it could be. See where it goes. Was this Sun Ultra? Is it got some like MIPS CPU or something? Other than a cold, I caught them. They're fine. Yeah, there's been colds going around. I caught 2 colds. I caught like one a week or one like 3 weeks ago, and another one like last week. Yeah, I think we got COVID. I don't know, in one of them. But yeah, I've never been tested, so I've never had it. Spark 64 bucks, of course. Awesome. It's interesting. I've never even ran anything other than x86 and ARM on anything desktop-y. Obviously, I've used like a Game Boy or something, which is some other CPU, but yeah. It's just, yeah, there's a lot of different architectures out there that I've never played with. So what's this shader even supposed to do? Sort count. So it's FFX parallel sort, right? That's where you read it. Then this is a separate thing, count event, right? So this is meant to be a sum table. Do you think it's meant to be accumulating some kind of sum, right? Some addition. So it populates it with 0. I'm not sure about. So why is this only printed 16 times? Because it only does 16, right? This should be 1024 on it. 128, okay. Right. Right, so do a bunch of 16s in the same, right, wave. If there is any. So you clear all that to 0. Non-blocks process, get the block index for this thread. Then your group ID, right. Pretty simple, it should basically just be 0. Count the value occurrence. So you're getting your source keys. Right, so you're loading at these indices. Parallel sort. Their index equals block index. Interesting. We should see this. So let's look at the block indices. It's got 768 megabytes of memory and 2 physical CPUs running at 296 megahertz. Wow. What else do you need in your life? Yes. See, imagine if you put Windows on that thing. Like, how bad it would be. I remember the days of like Windows on like old computers and stuff, and oh my days. You used to have to, when you logged in, you used to have to wait like 10 minutes just so you could press the start menu. And like, it was, uh, those days. Right, so you're in block index 0, 1, 2, whatever, right? Okay. There's this sort of incrementing thing. What's this sort of num blocks to process thing? How many blocks are being processed? 1. There's 1 block. So it's going over. So there's 1 block per thread group. Preload the keys in order to hide some read latency. So this is like thread group size is 128. Right, these won't load. Those go out of bounds. Holy moly. That's not good. What are they doing their samples with that load key thing? Right, let's do some gymnastics and get into the right file. Source keys. Right. Right, they just pull it out. Apparently. But then again, you don't really want to return 0. I guess they've got some ways of checking. They've got like a number of keys somewhere. Num keys. So they probably don't mind you loading 0. Because if you go out of bounds, you'll get a 0. And if you're unfortunate, it might crash. So if the data index is less than that, then you take that key from the source keys, do the shift to grab the 4 bits that you're trying to sort this iteration. Then atomic add it to this histogram thing. Right? Local key times this size, 128. How big is this histogram? Right, bin count, which is 4 bins. So 1 should flip 4, so that'd be basically 16. 16 times 128, so that'd be 1020. Oh no, it wouldn't. Be 20, 48, wouldn't it? There's 2K of memory. Or 2K of 4 bytes. I think anyway. Yeah, so the whole thread group can write into there. You clear all of the buggers to 0. And then you're summing in there 1, which we only saw 1 go in. Is that what we expect to go in there? Yeah, so you only expect this one to get done once. Number of parallel elements per thread. Right, this will go 4 times, but this will only get triggered once because your data index will be the block index. So we saw from the block indices it would just be increasing by that. So you'd only write effectively a bunch of 1s in there. Data index. Yeah, I think this is correct. It feels correct. You get your key, right? Put the key in there. We'll then get this sort of like place it gets written into in the histogram. Just to have an idea of what the hell's going on. So we'll just write the word histogram in there. Right, so we've got 15, 14, and whatever, and then it goes into these slots in the histogram. Apparently. Does that change every frame? No, it doesn't. Interesting. So local key multiplied. That's interesting. So it gets binned into the histogram. Into these. Right, so you need 15 multiplied by that. So you're binning it. Well, you're summing how many things land into that thing. That sort of slot in the array, basically. You're just counting it, isn't it? So you're binning them into the same thing. So I imagine that's all just fine. Then you're going over your histogram. What is this for loop for? You have your local ID. Yes, you've seen how many there is. Okay. I think I'm okay with this shader. This one looks correct. Let's look at the next one, see what reduce does. We should not be seeing a bunch of ones, I think, in at the end. So the next one is reduce count. See what the job of this one is to do. So reduce count. Windows doesn't run on Spark, it only ever run on x86, PowerPC, MIPS, and Alpha. I think they've got an ARM one now. But yeah, modern day. Windows is still like that. If the machine is old in 3 years. Yeah, I think you mm. Yeah, it's definitely like a lot slower than Linux. Just another reason why I use Linux is because it's just a lot faster. Things are basically instant. You don't need to have the latest and greatest hardware. But yeah. And when you start installing a lot of stuff, Windows does get slow. Or I've used it and filled it up with stuff. Nice, checking whether byte ordering is big Indian. Yes. Amazing. You are now aligned with the network Indian. I'm also quite impressed. I booted NetBSD from FreeBSD ARM64 box over the network. It's running entirely with root over. Oh, sorry. With root on NFS like a charm. Huh. Nice. You had a chance to dabble in the BSDs. Which one is your favorite, Nico, of the BSDs? The FreeBSD? Or you got like different favorites for different tasks? I know you kind of use a few of them. So reduce cam, what is the job of this one? I forget what the word reduce means. I need to learn this. So there is wave intrinsics. I think called wave reduce, right? My am I speaking incorrectly here? Prefix count. Yeah, because I've seen it in the Spear V and Spear V, right? This is where I've seen it. Reduce. Wait, is here? Here we go. A reduction operation for all values of a specific value x. So I think what this does is this uses is prefix sum. Uses this reduce thing. So it's all the ones that come before it in the wave. I think it's something like that. Yeah, it's like a prefix min or a prefix sum. But maybe that's different terminology. But maybe that's right. It's reduced count. So I guess there's a prefix. Yeah. Active sum. Is that meant to be a prefix sum? I remember that being a prefix sum when I copied the code over. Hold on a minute. Is that the problem? If so, oh yeah. Right, it's fine. Let's get back into the right file because there's like a gazillion files. Thread group reduce. Okay, it's an active sum. Damn it. No. Right, where's there these prefix sums? Scan prefix. Let's check that. Prefix sum, okay. But anyway, let's get back to this reduce count thing. And figure out what this thing does. So the input comes from that sum table, and it's just a bunch of ones. So let's just double check again. It stores at index 0 to 15, it just stores a bunch of ones. Of course, FreeBSD. And if machine doesn't support a FreeBSD, then NetBSD. If you wanna dabble a bit with a BSD box, send me an email and I'll get you set up. Nice. You haven't really got anything yet, but you know, if the world of Manjaro or Arch Linux goes to crap, I might move over. FreeBSD is getting better every year. But yeah. Yeah, so we're just throwing a bunch of ones in there. That seems correct. So where is it getting these values from in the next frame? So if we check the setup code, that was the one we did before. I said next frame, the next shader. Sort reduce. So the sum table goes in, and it's using sum table. Okay. So there should be a load sum table somewhere. So here's the entry point. Right, so it loads a sum and then it accumulates a sum in the thread group, right? So let's just start simple. Let's see what that is. Let's see what get the base index for this thread group. Let's just print these boys out and see what we find. There's too much information on the screen. Bunch of zeros, and there's some ones that pop up every now and then, right? So where can I get something that's sensible? First thread of a thread group that writes the reduced sum out. Right, so let's get into here. Maybe let's sort of see the output and just be like, So the input. Alright, let's see this information. So we should only see 16 here, I think. Right, this is great. So it's all out of order, which is fine. So this is where the bunch of ones are still going through. And I think that's correct still. But I don't know what it means by reduced sum. So it's looking throughout the technically pass with some entries. Because I wonder if these should be, if this should, instead of reading 11111, it should read some incrementing value from 1 maybe to 16, right? Because I don't know, it's meant to add all the previous ones up in the histogram or something like that. So let's just ensure that this output is correct. So figure out what bin data we are reducing. So you get the group index divided by the reduced thread per bin. Right, those are correct. I remember these getting set up correct, right? Yeah, I didn't change any of this. This is all just code from the AMD thing. I think I did just double check it was fine. Let's do one more double check. Where groups to run num blocks. Right, so num blocks, if I run up num keys, yep, block size, cool. Num groups to run is max. What is that? Max groups to run. Oh yeah, that gets passed in this called. Right. That's fine, num blocks. See, I wonder why that. Is this the CPU side? And GitHub. Oh, you're the worst. Well, let me copy and paste. Yeah, so that's where the constant comes from. So that's correct. The number of district blocks with 3 is that. Yes. Yes, 1 number blocks and then reset. Yeah. So this is all looking good. No biggie there. Reduced is. I didn't change any of this. That's all fine. So yeah, very nice. So back to where we were. Is parallel sort an existing algorithm you implemented, or are you just trying to make an algorithm more parallel? Hey there, Taylor, how's it going? It's been a while. So basically, you know, AMD's got this thing called, they got the Fidelity FX stuff, right? English. There we go. So basically, it's this guy. It's a radix sort, and I've poured over it. It's written in HLSL and GLSL. It's got if-defs and stuff for both. But I've had to port it to my custom shading language, and then it just doesn't work. So I'm just debugging what the issue is. But it's pretty decent because you can sort 32-bit keys and a 32-bit payload additionally, which runs in another array with the same indices. So you can sort 2 arrays at the same time, basically, with one being the key. So you can essentially sort a 64-bit value, which is great. And apparently it's really optimized. It seems pretty good. I've been looking at the... Well, yeah, I want to try on big data, basically. Yeah. This one they did their particle sorting thing. We're doing something similar, I guess. We want to sort a bunch of spheres and into some tiles. So it should be good fun. Oh no, it sounds like fun. Doesn't it work? As in it doesn't finish sorting. Yeah, so basically it's all scrambled and it's not sorted. And I'm just like, ah. So I'm just doing the first 16 bits because it does 16 bits at a time. And just trying to get that to sort, and then the rest should just work. But yeah, we'll see how that goes. So I'm just sort of going through each shader. There is so there's 4 bits at a time. It sorts the first 4 bits, and then it does like 4 different or 5 different shader passes. So I'm just reasoning about the input and output of each of them. I tested the end, and the input seemed a bit weird. It was 0 for the first one, and then 1 for the rest of them, and so it was all writing it into the same place by the looks of it. So I'm just seeing why that is. So we're on this reduced count one now, and it seems like it's just got a bunch of 1s. It's run a bunch of 1s into there, so I'm just wondering why. So it's something within a thread group. So if the data index, so it's base index times I, right, plus local ID. So I guess it's doing a bunch of consecutive yeah, so I think so the group ID plus data index. Hmm. Right, so in this histogram, it's in a local key. That'd be 0 to 15, right? Multiplied by some size, plus some local ID. And then it'll atomically. Yeah, so if there's multiple ones, we're going to the same one. But I wonder. This is just loading from that table based on some bin offset. Plus some data index. And it's skipping by a whole one of the 128s. So I'm wondering. Yeah, so it does make sense there are a bunch of ones, I guess. It's just the way they're spread out across the histogram. So this, I guess, is correct. Okay, so let's. This will what this will look like in the reduced table is. I still don't quite understand it, but do a wave local reduce. First lane, so you sum everything together. The 16 or whatever, 32 threads sum. And then you put them into LDS memory if they're the first lane, based on the wave ID. And if you're not the first wave, if you're not the first wave, then you sum. You sum all the other ones, I guess. First wave worth of threads. I don't know, it's questionable because I guess it puts it into an SGPR. Maybe? I'm confused. Why? Because surely one of the threads is not good. That's not gonna. That's what their code does, so. Thread group reduce. Hey there, Rizuma. Welcome, welcome, welcome. How's it going? It's been a while. Are you still using the GPU or is this all CPU side? No, this is all GPU. Yeah, so this is just compute shaders running. Yeah. So it's quite nice. Yeah, I don't know if you've seen, but we've got this sort of like this is like 2 million spheres rendering. It's about 4 milliseconds at the moment. But if I turn on this occlusion culling, it goes to like 1.4 milliseconds. But yeah, I want to try and. It's got some glitches though. I want to fix the glitches and improve the tile binning, and because it bins these guys into tiles, and fix this flickering as well, and see how many spheres I can push, basically, to the screen. Yeah, it's all using CSPV stuff. Yeah, custom compiler. Yeah, I was hoping to get way more though, because that's only one instance. I want to have many instances. That's the plan. I'm sure. I'm sure we'll get there. Just gotta wrangle together some of the GPU code and just get it perfect, you know, because it's fall apart any moment. Um, right. So I think we're putting out the correct value basically. So let's trust this one and move on to the next one. You know, I'm leaving those in. I don't know why they did it without these. Brackets are the way. So the next one is some form of like, it does it for one thread, and it's gonna. It just looks at the reduce scratch buffer, so the one you wrote out to, and it uses that as some scan source and destination, and it does something on it. um, so let me just double check that again. So this dispatching stuff here. So it does this one, right? It does a bunch of ones. Scan and source. Yeah, they use the reduce scratch buffer. There you go. And this one uses the scratch for the sum. Wait. The reduce pass uses the reduce buffer there. Sum table. Yeah, right. Right. I think we're all looking good. The game's end goal in mind. Yeah, I have one written up, but I'm not setting in stone on it. It's in my repo. I haven't gone over it on stream though, but it's here. I want to get the graphics done first and know what it's visually going to look like and feature set there and what sort of tooling I'm going to have. And then I want to probably look at that idea again or look at some other ideas or think about some other ideas and just pick the one that I feel like would be the best to do. I don't want to commit to anything too early, you know. But I'm just building up the essentials that I need right now. All good. Starting to have the need for introspection, reflection. Not sure how to do it other than go metaprogramming. Oh, interest. All right. Yeah, but do you have the need? You got it, yeah. No worries, Taylor. Good to see you. No worries. But yeah, have a good rest of your day. I'll catch you later. Thank you, thank you. But yeah, metaprogramming. You can always convince yourself to have the need for metaprogramming. Uh, but yeah, the best thing to do is not. And if you're going to do metaprogramming, what I would suggest is if you just write a C program or whatever that generates a source file, and it does it as it only generates it when you need it to be regenerated, and so you see all the source code, and you can actually put breakpoints in it, have a play with it, put comment, you can tweak it without regenerating it to test stuff out. Um, yeah, I wouldn't. Yeah, basically just do your own code gen if you're gonna do it. So this sort scan. What's the input and output of this? Okay, so the input is all the ones that we saw. So it does like a scan, sort scan. So which one is the last shader before? Right. So this is the guy that outputs a bunch of zeros. So, but let's still look at this one, sort scan. All right. Right, I remember looking at these and I was remembering that that is correct, but I don't know, I want to look again. I want to double check. It's a sort scan. Oh my days, where have I gone? Oh, num scan values. Did somebody have a typo? like me? Did somebody like me have a typo? I think I did. That could be the problem. Right, let's hit F5 and give that a run. Oh, I don't think I got the print code anymore. Scatter, end of scatter. Let's drop it in and see what the final sort is. I think we found our typo, guys. This better be it. Offset and local key. In we go. Oh, they're sorted. Oh yeah. So, right. I'm glad we found the typo now, but is that the fix? Because that's just the first iteration. But I would like to hope that that was it. Because this, they did test that the code did work. So we're up it to do the next set of bits. Yeah, let's make it do all the bits. And I think we'll increase the array. Sort. Right. Oh, this is good. So, what am I doing? Let's make it 32. So it does the next one as well, right? The next set of. The next one will be like 256, I think, right? Values. Yeah, let's make it do 256 values. I think that's right, because 16 times 16 is 256, right? Oh, not game controller. Right, maths. So let's put in these 256 values backwards. 256. Alright, so we're uploading 256 things into there. Got to make sure the buffer has actually got 256 spaces available. Alright, so compute construct. Right, we've got 1024 room. So, now, if we are to sort these boys, which means I now go to, where am I going to? Make persistent, I think it is. This is where we have our volume constructor and we... Yes. Oh, for crying out loud. Okay, so it's only going to show the first 32. Maybe we can make it do a few of them, but... So if we do that, I might, like, SV dispatch. But I might make it do multiple. So it might look a bit skewed. Or a bit out of order, but that's fine. As long as these are equal to the index is equal to the value, then we know it's been sorted correctly. So I kind of want to say, oh, this one is plus... we're doing 32 at a time, yes. Plus 32. Plus 32. This would be plus 64. And then, like, the final one is plus 96. If I know my maths. So, oh. Crap is wrong here. Oh, there's pluses. I didn't like the pluses. Oh, because these are dot x's. As a vector. Holy. Not sure I understood. What is a bad version and what is a good version you were mentioning? I'm just saying, like, don't... Oh, okay, but the metaprogramming. Yeah. So if you're doing, like, a bunch of, like, C++ templates, like, okay. Like, the first thing I'm saying is if you don't have to solve your problem with metaprogramming, then that's automatically a great win. because metaprogramming just makes your code more unreadable, harder to debug, more complex. I guess that comes with the other two problems because of that. It's more complex. And it also can increase build times. So I'm just saying, make sure that if you... Yeah, it's easy to convince yourself to need all these, complex solutions. But the first thing to do is make sure you don't need metaprogramming. What problem are you trying to solve exactly, Rizoma? So what's going on here? Oh, right, it's got occluded types. I need to... It's a wrapped integer. Okay, right, here we go. Oh, yeah. So they're equaling to... Right. It didn't do the two... Oh, yeah, sorry, it didn't go up to 256, so I didn't print those. But, yeah, this is looking good. So I'm liking this. What I want to do next is... what I want to do now is I probably want to test the indirect version. So the indirect version, and you'll love this one, is that the count is stored in a GP buffer somewhere. And we're going to need this. So I just want to double check this works. So this one is going to be like, oh, this it's in the global buffer. I don't know how to do this. Oh yeah, GPU global buffer res ID. So we get the resource ID for that. And then we give it the offset. So the offset of, and we'll do some sort of like test sort count. We'll call it that. It's, yeah. Anyway, maybe we'll do lowercase gfx globals. Right, so let's find that. Right, so in here we'll just, this is all the CPU side data, doesn't really matter. So we're going to upload it from the CPU, but it's being a GPU buffer. So you can set this at any point in the shader, in a shader somewhere. But we just want to make sure that it's able to read the value out and actually sort stuff still. So if we go into where these globals are actually initialized, so this is the CPU side that sets stuff up. And we're just going to poke in the value. So we want 256 in there. And then we want to fire that away. And then see what happens. Here we go. Right, so still sorting. That's great. So I'm happy with that. So the thing I haven't tested now is the payload thing, but I assume that'll work. And if I were to disable the sorting for a minute, just so we can see that it is actually working, right? This will be inverted the other way now if we run it, right? See? So we initially ran to the buffer back, the indices backwards, and is able to sort them from high to low, from low to high, right? So that's good. So something we want to look at now is, right, so I actually need this to be indirect. Now, where is it? Volume cluster construct occluders count, this one. So this is where the final count is being set into. So we go around and just, so when it's trying to make the occluders, it sets that to 0. And then we sort of just add into the array. So here's the occluders getting put into the array. And now, but they're all out of order because GPUs do stuff out of order. Now, I really need to do a debug thing again. I need to just get this working. Right, let's just get those center things. Yes, these. I think that's right. Center position and half dims. Wait, is that unorm though? Right, those are the unorm ones. Okay, so that'd be nice to view. Right, so the problem is it's sorting it from low to high, whereas I want a high to low sort. So that's just indexing the array backwards. Because my key, if we look at the volume occluder, the volume occluder is packed like this. So it's not 2D pack this into a single, because it already is. So there's 3 bits of LOD. So that's the most important thing. This is in the highest bits. And this is the key, right? So, and then cluster coordinate is next important. So what I want to do is I need to index from the back, basically. So I need to reverse index. So there's a count somewhere. It does a min based on the max number of occluders. So I want to get this. I want to say source index, occluder source index, and we'll document it here. What we're doing. Sorry, minus that, minus 1. So we'll say occluders. Sort is low to high, and we want high to low. So index from the back of the array, and voila. So that will then populate us with that. I think that should be good to run now. Yeah, maybe premature. I'm normally started just creating headers for some asset metadata. Then and now, I have the need to talk about members of a struct as particular inputs to check in a circular input buffer. Now I was using an offset of to do that with a bunch of macros talking about the actual member. Just try, instead of refactoring my input types into an array enums, I just had the impression that doing some reflection stuff would be handy. Maybe it's asking for troubles. Yeah, reflection is kind of nice. Like having reflection information is kind of nice for a few problems. But yeah, so like serialization is one of those, right? Having some kind of reflection data is a good is a nice to have. There's also some other reasons, but yeah. Talk about members of a struct, particular inputs. Right. Yeah, I see what you're saying. So he's manually basically providing offsets into the structure and passing that information in. So you're already making your own reflection data basically, right? But hard coding it. So yeah, what I would recommend is yeah. Yeah, you can. In the past, I've done something like that where I've had like serialization and I've made type information and sort of passed that off to the serialized function. Yeah, debugging is definitely difficult because what happens is you pass in a um you essentially pass in a bunch of data like a it's data driven, and you pass in that table of data, and what happens is it's some recursive algorithm that goes through a bunch of type information, and it's quite difficult to be debugged sometimes. But yeah, it's not that bad. I was fixing what is the first member and last member, kind of janky. Vulkan first take last, right? Yeah, yeah. I wonder if have you seen do you follow Mr. Ryan Fleury? He's got this is this what it's called? Metadesk there we go. So essentially it's like it's not he uses I think he's got a blog on this sort of stuff as well. But he essentially you write this sort of like um it's a code generator basically. So it allows you to do meta programming. So you make your sort of like I wonder if there's a good example. Type metadata. Yeah, so you essentially make your types in this sort of syntax, if you will, and you have this C program which parses this file, and you get to code gen whatever you want. So you can code gen a bunch of tables in C or something like this, or even code. So yeah, you can use it to code gen to do meta programming basically. And it's not some crazy template stuff. And you see a final output at the end of it. He's got blogs on it. Table-driven code generation. I think this is probably one of them. Yeah, I think this is it. I remember glancing over this. But yeah. Yeah, I think I'll drop a link to that. Yeah, this is his thing. This is not really it, though. He's using his meta-programming stuff there, though. Yeah, I don't think that's exactly what I was looking for, but I think he's done some blog posts. Yeah, so that data type didn't check these examples. I may have saw it in a talk. It looks something similar to a bit like JSON. I'll check it out again. Awesome. So back again about the good and bad stuff. Huh? I'm not sure you mean exactly. What are you referring to? But yeah. Right, so there's an occluder. That's an occluder apparently. It's wrong though. This white box. So this this yellow box is like just debug viewing all of the occluders within a volume. This is an instance of that volume, and yeah, we'll just ignore this and all of its pals that are being rendered right now. So this space is where we should be seeing the occluders. We're only seeing one of them. Do it. Crying out loud. Kill game. Right. So these are obviously the wrong occluders. I wasn't asking for these. These are zeroed occluders. Where that occluder strut that we saw is 0. So it's not what we're looking for. So something is clearly wrong. Oh, we didn't store it. Oh no, we did store it. Something's still wrong. Right, let's double check stuff. Right, we initialized that twice. Not a good idea. So that was allocating 2 buffers, but that's not what we wanted. So we should remove this upload code now. It shouldn't exist. We should also 0 this buffer for debug purposes. So the make occluder setup, then it makes the occluders, then it sorts them, and then does the make persistent. Right. So I should put them in there. Ah, it's not getting... Right, it's not doing the reverse search, is it? And also, Whamsy, if you go out of bounds, that would kind of be a bit sketchy, wouldn't it? That is not good. So you kind of want to have this thing here, and then do that as well. And I guess you want to do something like that too. Right, so let's right, we've still got a bunch of zeros. It's not good. So how many occluders? Do we disable the sorting? How does it look? So I've disabled the sorting. Maybe... Right, so maybe they are simply not being instantiated properly for some reason. Oh, here we go. So I plugged them in, and here's when they're not sorted. So there is input data. Here's all the occluders that we should be seeing. I wanted to sort them though, so it wasn't as jumpy. So we're seeing data, which is good. So how about if I enable the sorting then? Do we get anything different? Or I just see a bunch of zeros. We can open up RenderDoc and just have a look. You're saying something... Something... Maybe take... Like, don't go into template stuff, maybe... Yeah, so it was... Oh, no. I still stand by no template stuff. Like... Basically, it's better if you code generate what the templates will essentially be doing behind the scenes, because then you can actually debug what is going on a lot easier when you do metaprogramming. Templates are also harder to read. If you have a file which generates another code file with all, maybe it's a bunch of lookup tables for your type information that you're doing, or maybe it is a bunch of functions which do something. So you've described what you want to generate, and you generate those functions. I feel like that is a lot better than having templates because it's a lot easier to debug because you're seeing the actual final result of the code, right? Basically. And you can regenerate that code file once when you need to. And whenever you make changes to the description file which describes how to generate, then you regenerate it again. So you're not doing that every time you compile, right? And stuff like that. Did I comment anything out in the sort? I didn't. Right, here's the sort stuff. Yeah, no worries, no worries. Right, where's the bugger? Cluster. Constructor occluders, excellent. View contents. I've seen a bunch of U32s. But it is a bit filled. I wonder how the bit fills even work in this. Oh, for crying out loud. Right, anyway, that should... There you go. Right. They're nowhere to be seen. Amazing. So let's go back. They obviously get set to something here. And then they're nowhere to be seen. Oh. No way, it scatters them back in there. On the second time around. And it puts a bunch of zeros in there. Crying out loud. I was thinking they're the low bits. Ooh, that's not good. Anyway, the low... Minor issue. Hey there, Sleepy Mushroom, how's it going? How you doing? 2 seconds, I think the baby's just woken up. Let me just correct him. I'm back. Up it is. Right, welcome back, everybody. I was going to start graphics programming. Can you advise lecture sources? Any C++ stuff would be great. So Xandra, right, Sidus, I guess. What I can recommend, it'll be a little bit, right. It's an interesting take, I can tell you that. So what I recommend is starting off by doing a triangle rasterizer CPU side, right? I guess C++, right? Whatever. But yeah, so following some samples like this, yeah, so you basically rasterize your own triangle CPU side and see exactly how, well, not exactly, but just, what's going on under the hood in OpenGL, so or other graphics APIs. Yeah. Why is it two people with similar names? So start there, figure out, the maths behind how to rasterize a triangle, what kind of goes on, right? You can make it render out to an image, right? You can use something like STB image and render out a PNG file and get started there. You don't have to render to a window because that's just more complicated. And then I think so isn't I need to find. I've suggested this to a few people, but not so read in the Discord. I gotta find it. It's great. Here it is. So not so red. If is he did this and he took it to like level 10. Like so he did a software rasterizer in C, so it's triangle rasterizer, but he made it sort of like kind of be like Vulkan, but it's far simpler. So he can understand like how Vulkan works under the hood. So these are some renders that he's done, and he's implemented like some CPU shader based system, configurable pipeline, blending, alpha testing, texture sampling, face culling, and stuff like this. And he's got like pixel shaders and vertex shaders on CPU and stuff like that. So it sort of mirrors a simpler Vulkan basically. So yeah, not so red. There we go. Let's open your shirt. So basically, he's got some links in there as well, like that he looks into. And I guess he's gone and made it render to the screen as well. So looking to do something in between those two things or either one of those, that is also good. Highly recommend. A good way to learn. How's it going, Red? Not bad, not bad. I thought we fixed the sorting stuff and then no. We've just come across another problemo with this one, which is a bit weird. But yeah, he's gonna write. Man, I tested up to the 8 bits, and it's I'm looking on TV. Doing good. Awesome, good to hear. Yeah, doing good. Been super busy. I went into work yesterday, did the travel. It's quite long, so I spent like about 3.5 hours in the car that day. But yeah, good time though. Um, Yeah, so something I want to look into is a minor problem, but when you construct the oh no, it is zeroed. Hmm. So zero, the zero bit and the one, yes, the one and the two bit, if you will. So we should never be seeing twos in the data, right? Oh, for crying out loud. I don't think we should ever be seeing twos in the data, like a two there. So that's assuming that the second bit is maybe with one shift left, two. Let's just look at the bits, right? One shift left two. That's never being set. The two bit or the one bit. So why am I seeing two in the data? Yeah, drink water, man. Stay hydrated. It's the way to go. Um, yeah, I don't know why. I don't know why it's setting a few twos in there. It just doesn't make any sense. It's the only place that will like set it is in here. I'm not sure how much I can trust RenderDoc though. Let me print out the value myself because there's been a thing with RenderDoc where I'm just not sure if I trust it. Alright. So 0x percent x. Oh. For crying out loud. The data is different to what RenderDoc is saying. Why does it do that? Um so let's not do it in hex. Oh, we are seeing some twos. Right, what am I doing wrong? How's the program so far? Any progress? Yeah, so we've got it ported. We're trying to actually sort some occluders and get a stable set of occluders. After we've got those working, I want to fix this bug here where this problem, where this is flickering, and then properly sort all of the spheres into tiles better using this new sort shaders, basically. So yeah, it'll be good. I don't get how these values are going to have a 2 in there. Because your FC, they're all FCs, right? Which are just, they ain't got the 2-bit on. Ah! Right. Okay. I guess that's obvious then. Right. Yeah, that's obvious. Okay. Let's see now. Right, just misread that. Right, so the problem that's happening is these are our first set of in our sort function provided by AMD, which is nice. For some reason, this loops over like 8 times, I think. Yeah, run this 8 times, and it does 4 bits at a time, right? And sorts those things. So does it once, sorts things into a temporary destination buffer, and then it swaps things around, swaps the source and destination around, does it again, and then puts in the destination buffer. That source buffer that you passed in to be sorted gets the values the second time around in there properly. And so when it goes in there the second time, so we see a scatter, sort scatter. So this is the first one. It doesn't touch this data at all. But if we do it a second time around, and now it sets it to 0. All of the values to 0. Let's bug it up. So I need to figure out why that is. I thought I tested 2 iterations, but turns out I was wrong. So this is us testing it now. So we're getting a different view from it. What I want to look at is about the source keys. So I want to read that buffer now. So there's a source keys buffer. Keys scratch, this boy. So I've got the 2 buffers here. Well, this is volume occluder as well. It's just a U32. So this one got set to 0. It's problematic. Right, so where is it? Right, so here's where the sorts start happening. So it sets up the... Right, indirect sets up that. Does it count? I guess that does have to be min. There's a problem. This does atomic add too much, probably. So what about... The make persistent setup is too far. It doesn't matter, I think I can just do this. If it goes too far, sub it back by 1, and that should correct it. Maybe this is the issue. So it's asking it to sort too many, and therefore grabbing zeros from out the buffer, and maybe the zeros got put at the front and then it messes it up. Oh, that fixed it, I think. Let's double check that. Let's comment this out. Okay, so it wasn't a problem with the sort code. It was me. Yeah, excellent. Right, we're good. So at least we don't have to dive back into that sort code again because I wasn't happy with that. Right. So I'm happy to see that the occluders are actually looking stable now. They're actually deterministic. Like, same input, same output. This is being regenerated every frame. Like, the volume is being constructed every frame. It's not going to be like that. It will do probably one volume per frame. But once they're loaded into GPU memory, then they stay in GPU memory and they don't get regenerated. So this is being regenerated for debug purposes, just to see if things are deterministic, and it seems like they are. So specifically, as you can tell from this thing here, as you can tell from this thing here, it gets the biggest ones at first. These are the sizes here. And then afterwards it picks probably the biggest coordinate range. That's what it sorts by second, I think. Yeah, biggest X, biggest Y, biggest X first. But that's just a way to make sure it stays ordered. Yeah, so that looks pretty good. I'm happy about that. So we actually got things sorted today. Excellent. There's still got time left to do other stuff. So we could probably look into just seeing how they look when you turn these things on and test the performance. Maybe we can improve the occluder system, because at the moment this is like this ball, as you can tell. Well, it doesn't fill the whole volume, but yeah, this is the occluders that you get from it. It doesn't really go too far to the top. It kind of does here, I guess. Maybe we can always add more occluders. But yeah, we'll see those run into the screen in a minute. So I think we can maybe include the shapes that we use to use as occluders, and the other thing to improve is the rendering code that renders the occluders to the occlusion texture, because these are the occluders being rendered right now. See the blocks that are being rendered into the thing there. So when you're right up close, it's doing great. A bit further away, maybe not so bad. Yeah, so that's cool. Right, take a look. What is this? Running package source? Oh, thanks to the package source. So you got it compiling and working. Excellent. Nice. Now, what packages exist? That's the next question. What packages can you get working next? Alright, I'm glad. I'm glad. Glad we made it this far. This is good. So if we enable the occluders, we can see them in the occlusion buffer now. So, but then if we test it, if we reproject the depth from the previous frame, that's how good it can get. And actually, like, what you're probably not seeing, like, these two values are probably really different. These are far closer than these. So, and if you toggle this, you're not seeing any glitches here that appear. There's still glitches because that's probably something else. But this creates glitches because it's probably too good. Alright, so that's interesting. Should we look at the performance and see what sort of gains we get when we enable these things? Not that it's anything final, but yeah, it's just good to see what sort of gains we get, because we've still got to improve other parts of the pipeline. So I'm looking at... You want to disable these now, because I'm kind of okay with those. There's also some other printing that's going on. Is there? No, good. Oh no, I want to enable the profiling, want it? Sweet. Yeah. Pretty good. So, the reason why we need these occluders is because if something spawns in on the first frame, maybe it doesn't even spawn. Or maybe it goes from being transparent to opaque, I guess. Because I don't think we're not going to sort of pop stuff in. I think popping stuff in is just going to be ugly, right? But maybe there's a time when the reprojection depth is simply not good enough for some reason. Maybe the object moves fast, or maybe there will be or something, right? So we needed some sort of quick backup which renders some quick boxes into the occlusion buffer, basically. So if we do something like this here, we've got this like time down here, it's about 3 milliseconds. If I turn that off, it goes to about as high as 4. I don't know, it's very noisy. I don't know why my frames are very spiky, because they should be pretty solid. But yeah, now the high is probably 3 milliseconds here. So it goes up to 4 there, about 3 there. So yeah, as you tell, it goes up to about 7 milliseconds here, and then it goes up to about 6 milliseconds here when you turn it on. So there's some savings at least. It's not great. It can call the ones at the back, I think. Or the middle one back. But if you turn this one on, it goes from 7 to about 4, just about 5. That's a bit better. It's twice as good. So, okay. So I guess the next thing to do is we should look into like why is it doing too good of a job. You can see the clusters here, right? Like whole clusters just disappearing. I'm not occlusion culling individual spheres at the moment. I need to look into that, whether I want to do it or not. I think I will want to do it. Yeah, because they get spinned into screen tiles, so it's free. It's basically free to do it. It's less anyway. More stuff will fit to the screen tiles. So why is this happening with this guy on? So what I want to check first is like, how are we making the depth, and then how are we testing against it? Is the question. So we've got the depth buffer, depth texture, I guess. More readable that way. So I remember something. In the latest Sebastian Legal's video, he implemented a font rendering algorithm from a paper he said might give a try later if you want to improve your font renderer. Yeah. I actually watched that video. It's a good video. See, I actually really like that video because he basically was like, he did it from like a first principles type of thing, where he like tried to solve the problem like without doing it the way everyone else does it, right? And that was great. His final solution though didn't end up being, it had some problems, right? Because the winding is not always correct on some of the fonts he plugs in. But yeah, it was good. Good video. We should link that, so if people didn't know. This one. Yeah, it's a good watch. It's an hour, right? But you can do tons of squats in that time. You know, just do some squats, lift some weights, and watch the video. It's good. So basically, he did mention that Microsoft paper was actually had a patent, right? Or patent, if you're American. Patent, yeah. So yeah, maybe it's not a good route to go. Yeah, and he also mentioned there is the slug text as well, which also is a patent as well. That algorithm as well. But yeah, it's interesting though. He's thinking, you know, maybe he does a second version where he discovers there's a different way that you could render text, and it's quite nice. But yeah, rendering stuff using the Bezier curves seems better than SDFs. SDFs just seem like they have problems with a few things, and you have to like generate textures and stuff, and it's just annoying. It'd just be good if you could just use the power of the GPU and just do something a little bit more with the maths directly on the Bezier curves, basically. Yeah, it seems cool. Yeah, I've been saying it for ages. I've just never got around to doing it because it's just such a problem I don't want to solve yet, you know. Good text. So we write this depth texture. The one where you triangulate the glyph, that's pretty interesting to me. I might give it a go later. Yeah, someone actually said they did that. They posted about it in the yeah, someone said they did that in the stream, and they come by and said it. And I was like, it's a lot of triangles, but it's definitely a way you could do it, and you get some good looking text, but it's just not the fastest. I mean, you get subpixels, right? Subpixel text will look crap. I think that's always a problem, right? You have like a pixel, and then you got like an R character that's like that. Like, how do you render that, right? Like, what do you do? I guess maybe this is a bit too small. Like this R, maybe it was a bit bigger. But yeah, you get sort of issues with stuff like that. Triangle one. Because your triangles would be like, or maybe it'd be fine. Because you might have a bunch of teeny triangles. But yeah, the center bit just has to go over that sample point, and then you're in. Oh, the one in the paper, right? With the yeah, that's with the Bezier. Oh, then it does the right. I know the one you're talking about. It does it with the Bezier curves, where it'll like spawn little triangles on the edge that had got a different shader, so it will like right only color in this part of the triangle and not this one. But yeah, it's got the expensive shader on the edge. Well, the more expensive shader, if you will. Yeah, yeah. What kind of game are you making? I've got like an RPG down in some design doc, probably turn-based, but I'm not sure if I'm settling on that idea. I want to do it right now, but there's a lot of time until I actually go and get to that. So we're starting on some rendering first. We're trying to push as many balls to the screen as we can per second, right? So I want to try for gigaballs per second. You know, teraballs just doesn't sound quite good, but gigaball sounds better. You know, I would much prefer a gigaball engine than a teraball engine. You know. Anyway, I think I milked that joke, but yeah. So we're focused on the rendering first, trying to find a kind of unique art style, and gonna start there first. Yeah, it's not. Yeah, it is. The hardest thing is you have to sort of. You've got a big list of things to do, and you've also got a big list of potential things that you could do. And you often want to take this potential list of things you can do and do all of them. And the whole point is you need to try and find that finite list of things that you need to do. So you trim all that. You'll trim all the complexity you can out of your game. But also, us programmers find it fun by doing stuff that's complex and hard. So we often want to do a unique, not use triangles and do our own custom renderer with ray tracing and have it hyper optimized. So yeah, we basically make it hard on ourselves. That's one of the big things about it. But yeah. So yeah, this depth texture gets the closest hit in the depth texture, right? And then so it gets it from the previous frame, it gets that in the depth texture. And then at the start of the next frame, we take the depth texture, we get the depth. We've added a bias, right? Where it's just more depthy. There's more depth. Yeah, we probably need a bias. I think we need a bias. So I wonder if I increase this bias value, does it fix our problem? Say if I increase it by 10, does it fix our problem where we enable the reproject depth? Right, it doesn't flicker anymore. Right, but also it probably doesn't help us. It helps us a bit. It still helps us actually. Interesting. But let's not. I don't think that's the problem. But let's just have a bit of a think. So the other thing is when we do the occlusion testing itself. So you got this sort of so you got this occlusion texture now. You've got all these lovely MIP levels, so you can do a quick check. You got this occlusion texture where you got the depth in there, and you've got these lower MIPs where you're basically allowing yourself to sample a few pixels, or I think it's like 1 pixel or something like that. You sample a pixel and just be like, what is the depth here? And you can use that as a value where you say, if my cluster I'm trying to draw over this area is definitely more than this, then yeah, if it's more than that, then it's definitely occluded. So we'll look into that. Is occluded. We got this boy. So let's figure this out. So you got this sort of object depth that gets passed in. What is object depth? Closest depth. Let's double check this. I've got a function somewhere. Yeah, but the closest depth, isn't it? Yeah, along the ray, closest depth to the yeah, closest depth to the I wonder if we can draw that nearest point in a different color, like a blue or something. Be a bit of fun. So this debug drawing in shaders, which is really nice. So I want to do I got like an ugly blue, but I also got like a cyan. But I think I already used, I haven't used cyan. Well, I'll keep myself interested and motivated, and doing hard things is a good way to do that for me. Might be a psychopath, exactly. Yeah, that's the reason why you do it, right? Is that it is more interesting. It's fun, and when you achieve something good, you're like, yeah, the dopamine you get from that is great. That's in view space. I need it in screen space. Bum, bum, bum. Right. So let's render that. Yes, it's that cyan point there. It's a little bit wrong still. But yeah, it's picking the right one. It's picking the right one. Good, it's good. That's the closest point on the box to the camera. Cyan one. It's good. So if I turn on this, it still flickers out there. If I move, oh. It just seems to be on the top right at all times. But it sometimes moves with the camera. I'm ignoring this one for now where it does the breakaway. Yeah, it's always to the top right, kind of. Alright. Cool. So that's good debugging there. What's the next thing to do? Right, so we'll produce that closest depth, which I'm happy with. Sure. Yeah, because okay, I'm happy with that closest depth. So we get that closest depth out. Out screen browser 3D ABB. And then we pass the closest depth into here. So what are we doing? So we've got the bottom left and top right in screen position that we want to say, hey, is this cluster being occluded? So an example of that is this green box. This is that bottom left, top right thing, this green box. You got this 3D ABB, and you're essentially putting the box around all the important vertices. Right, so these red vertices, basically, this red one. The red ones are the important vertices for that time. And we're able to sort of use those to take the min maxes of things and reduce the screen bounds. Now we're using that, getting the depth of our object, which is the closest depth, right? Then we're checking a pixel on the screen and seeing, are we? So we're scaling ourselves down to be a pixel, I think. Gotta read that. Through 7 years from just being a graphics designer, I have my own decent 2.5D engine where it looks like a game is running and not just a gimmick. I don't know. This lands on the scale from dumb to smart, but here we go. Yeah, it takes a lot of time to learn stuff, and also it's really difficult to think, to sort of like know what is the right thing to do. And I think a lot of the time you have to base your stuff in like in facts, basically, right? And a lot of the time we don't get taught. Any reading material that you look at doesn't teach you how does the stuff work under the hood. So one of the biggest things is like how many parameters you pass into a function, right? And there's like two things, and like do you pass them via pointer or not? And you know, there's like two aspects to that. There's like do you pass by sorry, you want like readability, and there's one thing you want also like usability when you sort of use it the other end. Too many parameters is kind of hard to remember and all that stuff as well, right? And you also got like a performance thing in mind as well, and how it works at the low level. And until you have like all of those answers, if you will, do you truly know what is the best way to structure a function call, right? Like your parameters. And that takes a long time to figure out, or at least took me. I never really knew what, the best way to put parameters in a function. Some people just do whatever and they just chuck tons of stuff in. And I guess you could take it purely from a readability point of view. But yeah, there's just, there's loads of things like that in programming, and architectural things, and also just learning new disciplines within programming. Hey, hey, not so red. Yeah, you'd see me struggle live. Have any tips on learning how to use such create graphics in CPP? Ah, I've just been over this one. Right, not so red. Getting another plug. So, I need to like bookmark this. I can just type in not now. This is good. So basically, what I recommend is if you start, not AMD, writing a triangle rasterizer from scratch in C++ or in C. C's better. You can Google for it. I'm going to give you one that I've Googled for. Rasterizing a triangle by yourself and figuring out exactly the sort of maths that is used in OpenGL or Vulkan under the hood to rasterize a triangle to the screen. So there's this sort of lesson here, and then there is there's also other ones that you can Google for. But yeah, I've said this to a few people, and there's a prime example which is not so red here. He took this like to level 10, basically, where he wanted to know how like the Vulkan API works because it's bloody complicated. And what he's done is sort of, I guess, it's me guessing, because it just looks kind of similar, is he's looked at how sort of the Vulkan API works and tried to sort of do his own simple version in his software renderer. So he's got like vertex shaders, pixel shaders, and like pipelines, right? And has a way to sort of like kick off draw commands basically and render to the screen. So here's some renders that he's done with some lighting as well, which is quite cool. So he's got this repo here that you can also take a look at and get inspired. And also, I recommend, well, he also recommends some resources down here that he's used as well. Something that I recommend is do not, you don't have to worry about rendering to a window. You can just render to a PNG file and just check that. But when rendering to a window is nicer, but if it's a bit too much for you, you can just use STB image, for instance, and just write pixel data out to a PNG file and open that up and see it. Yeah, so stuff that is learned by doing this is like pipelines, blending, like a Z buffer, Z testing, texture sampling, and perspective correct interpolation and face culling. So that and more basically. So highly recommend doing something like this. But yeah, start with a triangle. And also, I guess in Notsa's repo, he's got these sort of backends for making a window and that. So maybe you could just, take his backends and get going, and get a window up at least. Yeah, it definitely gives me those vibes. But that's something like something similar I did as well. When I wanted to learn about how x86 assembly works and ARM assembly and stuff like that, I didn't really know. So I just basically made my own virtual machine and just sort of made my own custom assembly assembler, disassembler, wrote my own little programs, and obviously wrote and something that ran it as well. And doing that, I sort of learned how to read assembly and how x86 and ARM works. Because I made like a joint version basically between the two. So it's a good way to do it. Just make a simple version which is just emulates. Yeah. That's what I did the whole time. I kept rendering to an image, and then later, when I finished the project, I started rendering to a window. Awesome. Yeah, rendering to a window is a bit involved. It's a bit easier on Windows, I think. Like the X11 one is like... Right, so take this sort of bottom left thing, top right thing. Oh, take the bottom left. Yeah, so the width and height. Get the largest dimension. And then we... Oh, maybe we should max S it before doing this, because it goes off the screen, it gets a bit funny. It's doing too big of a thing. So you get your most significant bit, and then minute with the number of MIPS. Shift right by the MIP. I guess you want to max it with 1. Maybe. Because if not, you... No. No, you end up at coordinate 0. That's fine. So you get your coordinate, and then you fetch the texture of that MIP. Texture. Yeah, it's using a pixel coordinate. Rather than a UV, yeah. Then you convert it into a... Well, you do a reinterpret cast. If your object depth is larger than the occlusion depth, meaning it's behind it, then you're occluded. That just logically makes sense to me. I didn't see a problem with that. So I guess the thing we can do is we can follow... We need to somehow follow what the crap is going on. Somehow. So I need to sort of know... I need to know, like... Given a cluster, what is it? Where is it going? And what is it sampling from in all of this? I wonder if I sort of up this by 1 or something, do like a +1 or a take 1. Where do I end up? Oh. Right, I'm still getting the flickering. It wasn't as bad though. What assembler did you write? You meaning translating C? No. So I had a custom CPU that I made, right? In a sense, custom instruction set architecture. So I had like an add, where I could put it into a register, and I can add these 2 registers, right? And I just had my own custom ISA, and implemented all of the, like an emulator which ran. So an assembler which assembled this into a custom executable file, right? And then I ran that in a simulator which I also wrote, right? And it's a great way to learn like how assembly works, because you just learn it. It gives you a reason to sort of look into other things and make a simple version, right? No. It's just all this simulator is written in C. It's just a switch statement. It's just a switch statement, and yeah, takes the instruction, switches on the type of instruction, and yeah. It is a load of fun, but it's also incredibly pointless other than to learn, basically. Like, it's actually a lot of fun. Right now I'm rendering a single shape to window, kind of following Chiona's tutorial, while playing around with stuff to actually understand it. Cool. Yeah, I highly recommend you learn you do a software renderer. I'm not sure what Cheno's tutorial is, but I imagine that's using the GPU. Yeah, go to the GPU later. You can wait. GPU just makes things go fast and adds so much complication. um, right. So what could we do to figure out what the crap is going on? Like, I know I've added a bias. So if the object depth, which ends up being the closest point that we've looked at and sort of, right? We could be talking about floating point inaccuracies here. Maybe. I'm just thinking about the numbers that we're getting. I forget what the depth is on this one. We can check this quite easy. But then if we are, it's like I don't know. We gotta. So there's sort of like an if statement where we do a bunch of like oh, it's in the actual like this one. Well, we calculate the outer screen bounds of a bounding box. We never printed this. So this is on the first cluster. Closest depth. We're printing that out now. I should really disable the profiler because it's just spam in the terminal window at the moment. I'm not really profiling anything, so I don't think it's a good idea seeing that. We're now seeing the print data. I don't know if it's floating point inaccuracy. Will it be that? Just looks like it's not even that big of a value, I guess. So if we turn on that, you're seeing it flicker. So why would that appear one frame and not appear another frame? Because the depth of that pixel, bit of a play. I should see the color that we're putting in that. Let's make it like 100 now instead, and just see the different color. It could be that the tile bin is too full, and it's just not rendering them because they get too filled. But then, if that is the case, then surely that happen here. It'd be obvious. And when you're rendering less of them here, then yeah, that's not true then, is it? Good night, Red. Have a good one. Good to see you, my friend. Have a good night. No, OpenGL is not deprecated. It's a good way to learn still. But yeah, it doesn't run on Apple. But I think a lot of places still use OpenGL because it's just easier. Um, yeah, I think a lot of like smaller studios, indie games will still use OpenGL if they've got their own thing. Even some people just write application software that have their own custom renderer. They'll probably do it. Like I think Embergen uses OpenGL still. Um, but yeah, it's still going to be around because Vulkan is just too complicated. No, the sorting is fine. We just have bugs now. We're looking into bugs. Sorting is good. We sorted sorting. We just got this depth buffer. Something about it. I need to see like that's what we'll do. We got the mouse position. We got the mouse position in the global buffer. So we're gonna be like, if my mouse is over this cluster, right? Here's how good I do. Because it's there's so many here. There's absolutely tons of them. But I guess we can get the one right on the edge, and that could be helpful. Because then we'll get a little amount. Right, this is good. So I think what we'll do is we shall. Right, we'll not print that, but we'll take this with us. There's a is occluded thing. So what I want to do is kind of know what value you get in the depth buffer and like the occlusion. Yeah. So we'll say, oh, sorry, just smashed that mic. So I want to like um say if so I've got this like bottom left and that. So if bottom left dot x is less than graphics global's mouse position, this is going to be good. I need to get the keyboard in there as well because then I can do keyboard keys, but that'll come later. And if the top right is greater than or equal, less than or equal, greater than. Maybe I think it's inclusive. Yeah, it's inclusive. So in that case, oh yeah, we're gonna say, hey, what pixel MIP? So we want to say pixel MIP and depth. MIP depth. Greater than. Right, here we go. Got a lot of things. So bottom left is the sample point. Dot x bottom left dot y. Followed by the MIP, followed by the object depth, followed by the occlusion depth, followed by the result of that. And voila. So this is going to be amazing. Oh. There's no comma. Yeah. Maybe let's turn OpenGL to high level Vulkan with rap in the future. Yeah, I think they've already got that already. It's called, I forgot what it's called now, but it's yeah, it's been around for a while. They've even added some extensions into Vulkan to get some of the shaders to actually compile properly. Because in Vulkan you can't have global uniforms, right? You have to have a uniform buffer. So they've added stuff like that into it. Um, it may be Kronos having their own OpenGL layer that runs. They already have it. It's already around. You can Google for it. It exists. Right, here we go. So we get this lovely. Oh, no, 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 no. Huh? Why is it picking up on stuff? Is that because it's upside down? It starts picking up on stuff there. And it picks up on stuff down here. What is wrong? Oh, sorry, this is the bottom left post. Post doing this. Right. Alright. I need the OG bottom left. Right, maybe I need to say, is mouse over. Boolean is mouse over. There you go. Ta-da! Yeah, even if you are like yeah, so you're safe enough in GLN, but the the good thing to do, right, is write your thing in OpenGL, right? When you want to learn Vulkan and you got your project in OpenGL, you can learn Vulkan by point a project, and you probably will have to rewrite the renderer and some stuff, but it's a good way to do that, I reckon. Right, as soon as I go in this, okay, it's about there. So, oh, I should already move this thing, right? Things. Right, let's put it down here. Right, it's definitely not flipped because I'm going up here, I'm not seeing anything. As soon as I go into that box. Why are we seeing clusters? Oh, there's the root cluster. Right, that's a problem. There's the root cluster and all the children clusters and all of this. Right, okay, this is working good. Um, yeah, it's looking at infinity right now. Right, so let's do the reproject depth. I only want to see one of these. So what I need to do is look at the ones that actually got occluded. I think I should only do this if this. Right, which is a shame. But I think this is the way to go. No, it's not the right thing to do. Something like that. But that, why is that occluded? And also, right, I'm seeing a bunch of different ones there. Can't get too close. So apparently the depth is this sort of value here. It is about off by 10. How much is the object scaled by? What's the object scaling on that? Volume instance, I guess. So it scales by like 32. So every sphere is. So you got volume, which is like 128 spheres. So that would be 1, right? 1 is a. So you've got 32 divided by 128. So right, is it the right way around? Yeah, sphere would be 0.25. A sphere would be 0.25 in size, and a cluster would be 1. Cluster would be the size of 1 in world space, I guess. So it's got a size of 1. A cluster size of 1. These are way off. They're not just 1 off. They're like way off. So I'm curious, like, why. Like the depth of tracing array to that pixel the previous frame. Is it really off by that much? This is the box. Sorry. Yeah, this is the closest point from the box. This is the closest hit from previous frame on that pixel. I wonder if we say use the. I wonder if it's a result of the downsampling. But I remember looking at that and thinking it was correct. So if we reduce these down, let's just say it has to use the highest resolution. Right, let's just see what it does then. I don't know if that's a good idea, to be honest. Right, it looks. They seem to vary how much they're off by. Some is just a tiny amount. Well, I'm not sure if you call that tiny, but yeah, it's kind of. Oh, it's kind of tiny. It's about 0.5. And this is obviously a lot bigger. I use Manjaro, so Arch based. I've done Arch tons of times. Awesome. When you start this project, did you already know Vulkan? No, I already knew it. I already went through all the pain of trying to learn it. And writing like 5 or more different renderers. Yeah. So this time I'm doing a different challenge where I'm only using compute shaders, so I'm not using any of the traditional rasterization pipeline, which makes it far simpler to set up. But then like you've got to hand write everything in compute shaders and do stuff differently because you don't have access to triangle rasterization hardware, which does quite a lot of stuff, right? Like it writes the triangles to the buffer in the order you specify them. And it does that quick. Right, so I'm still a bit confused about why they differ so much. Like, what could be wrong? Like, so you write the depth. So you write the depth to the depth texture. That is that is the closest. Wait, do we have to flip the coordinate? Is it a flipping problem? It might be a. I don't know actually. Its closest hit depth. Um, is this ray tracer correct? It's a bit. This is me trying to do some anti-aliasing stuff, and it seems like it's going to be great. It's just not working right now because we don't do stuff from front to back properly. We need to still sort our spheres. This definitely needs a second pass. And it needs to early out as well. But basically we get the depth. Wait, what is that depth? Dot product. Ray. Oh, that's a different type. Oh, that's the anti-aliasing. Ah. Closest near miss depth. Do we use that? No, we just use closest depth. Or does this get put into the closest depth? No, good. So we ignore that. Not fussed about that. This ray versus sphere. Need a depth back there. I don't think this is the problem at all. It's the depth along the view from view space in view space whereas the view ray. Okay. I think I'm good. Right, I think I'm fine there. So this is okay. Then we saw there's the reprojection code, which doesn't reproject, right? It still reprojects, but it just copies it. Add some bias. Puts it in there. So then when we read when we check if it is occluded, we check the coordinate. Do we have to flip it? So it's written in unflipped, meaning so what about the debug render MIPS? This debug renders the MIPS onto the screen. When it reads from the texture, it does the flipping to get the value out and then puts that in on the screen. But we could have just flipped the destination coordinate as well, and that equally would have worked. That's only because the depth buffer needs to be, sorry, the final image needs to be flipped. But I don't think this is the problem. No, I don't think the coordinate has to be flipped. I think that makes sense. Because the way we could tell is if I put this to 0, if you see the problems only show in the center of this, away from the center of the screen, then Yeah, so the problem's sharp in the center of this out loud. There we go. So they show up everywhere, so it's probably correct. You'd see another ball moving through it if you was to move it around. I don't think it's a flipping problem. It is on the top right, kinda. It appears to the right more in some. When I move, I expect it to do that. I haven't reprojected it yet. Right, Rizoma. Have a good night, my friend. Have a good night. Thank you for coming. Appreciate it. But by default, it's kind of just wrong though. Right. I think I got an idea of what it is. The problem is because we're rounding down to the nearest pixel or something like that. If I were to offset this by 1, say if I why is it the top right? Yeah, say if I so if it goes out of bounds, it's not going to do anything. But yeah, say if we offset it by 1 here. I don't know if that's going to cause me problems though. But anyway. Right, here we go. Right. I don't think it's causing us any issues. Yeah, it's now on the lower left side instead. Ah, I think I found some problem. It's also not rendering when you get too close. But yeah, so the problem is now just changed. Right, it's changed to the lower left. Interesting. So it is what I think it is then. Excellent. So the problem, I think, I gotta try and describe this. So what you have is you've got this box and you've got all these different MIP levels, right? So you render. So I render this. I get a buffer of depth. I take that and then reduce it down. I reduce it down, right? Into the lower MIP levels. So downsample it. The problem, I think. So if you take this size, we go and say, hey, where is this a pixel big? Basically, what MIP level is it? 1 pixel. And then we will take it down to where it's just a pixel size-ish. Or smaller than a pixel, something like that. So what happens then is we end up just using the bottom left, right? After we've found the MIP where it is a pixel. We just take that. And then we say, okay, this is the occlusion at that depth. But what happens if this pixel has a different value and this pixel up here has a different value if there is a pixel and that one, right? Realistically, there's going to be a problem where this side is not going to be accounted for, if you will, in the test. So I think what we need to do is we need to do a sample or do like a gather, right? A gather a 2x2 area. That'll be off the screen. Be a gather a 2x2 area. And then take the. What are you going to take? The occlusion depth. You might want to take the max. Take the maximum or something like that. You gather a 2x2. Problem is, if I take him, if I take a min, that occlusion depth would be too good, and it could just occlude the object even more. Whereas if you did a 2x2, let's just test it out, right? We won't do a gather because that requires converting to UV. We'll do it in a minute. So say if we do a manual gather, 0, right, add U32 times 2, U32 times 2, 0, 0, there you go. So you got depth 1, depth, yeah, 0, 1, and 3, good. So then you're going to get the off x by 1, off y by 1, and the next y by 1. So we can probably use a more optimized function. But yeah, this will do for now. Test. Now you want to find the max of all of those. You do max U32, and you just want to do like 0 max. One, 2, 3. So we try that. We should hopefully have a fix. Let's give it a go. Oh yeah, excellent. Sweet. Man, I'm happy about that. So that's fixed the problem there. There's probably some other edge cases, but that's good. I'm happy about that. We've got to probably make that a gather. Oh shoot, thank you. Let's double check that quick. Well, no, it'll still be the same because it's the max. So we move it around. It's still right. This was the problem anyway. Yeah, we've got to fix this issue. This is a separate problem. This is different. Right, good. This is great. Yes, this can actually be done with a gather. So you do I've got a gather red or something like that. Gather red. You need a sampler, and I need to make it a UV coordinate as well because they love the UVs. Yeah, so that would be the performance increase. So I'll just to do make this a gather red instead. But it's actually not required, I guess. There. Well, we need to make it correct first. If it was this, if it goes out of bounds, then yeah, I don't know about that. All right, that's good progress today. So in today's stream, we got the GPU sort stuff working, which is super great. So I'm glad that's dealt with now. So we've got some sort functions, so we can generally sort stuff on the GPU. So we're doing more sorting later of data. We also fixed the problem with the occlusion or reprojecting it from the previous frame, which we don't quite do properly. So we'll have some glitches when you move it to the left and right. On the right, it will glitch there, and on the left, it will glitch when you move it. Got some problems to fix, so I've got to reproject the pixels properly. And probably add a bit more of a bias so it doesn't fail. Yeah, when you move away, it just glitches like crap. But yeah, I've got to add stuff like that. Fix stuff like that, you know. Yeah, maybe I'm not too fussed about those glitches. That's only if I want to make it good. Like, when I know I want to use this solution. Right now, the main thing we need to test. We've got these boys as well, these occluders. Cool. The main thing that I want to test now is how fast we can make it. So I think what we might do next stream then, since we've fixed this problem, is we might sort our spheres properly. So we're going to tile bin our spheres using a sorting algorithm, which will be awesome. So I think that should be a much better way to do it. There'll be less atomic rights, I think. Is that right? Would it be like... Yeah, I have a think about it off stream. But exactly what I want to do. But it'd be something to do with improving the bidding strategy of the spheres. Because we want to reduce this problem. Make it go away. By having that, reproject depth, we're not rendering all the spheres and filling up the tile bins. But this, if we disable it, it destroys the tile bins. Right, that does it enough. That's pretty good. Even though it's a loose version of the occlusion. Yeah, the tile bins just get filled up because the way I currently do it is quite dumb. It was kind of incomplete. But yeah, I want to do a proper version and just see how fast we can make it. And then we can scale up the instances and then see how good this is. And we can probably improve the rendering as well because this is jiggle. This is just like, yeah, this is bad. This is the anti-aliasing not working because it's not sorted back to front. Yeah, that's what we're doing next stream. That'd be amazing. We can probably close all this now, which is great. Oh yeah, good stuff. Right, so the next stream is on Sunday, 6 p.m. GMT plus 1. There's a YouTube channel where you can find the VODs. There is a Discord. There is I have a Twitter as well where I post stuff sometimes. Yeah, you can also, if you support via Ko-Fi or Twitch, you can get access to the code and run it on your machine. I think I will actually commit this code tonight, and I'll need to get it up running on Windows actually. There's so many things to do to get that to work. Maybe not tonight. I'll do it the weekend. I'll do it on Saturday or something. Right now I want to go to bed. Right, good night, Jam and Toast. Good to see you, my friend. No worries. Where have I seen? Oh, I see. I was just about to. Hang on a minute. It's playing Hollow Knight. I want the C tag. PS1 game modeling. Oh, more just popped up. Hang on a minute. It just reloaded. Right. I'm just gonna bail. Right. Have a good night, guys. Have a good start to your weekend.